Today's lesson is on percent yield. This has to do with the products that you get when you carry out a chemical reaction. Quite often we have a situation where we carry out a chemical reaction and you try to recover your product, usually by some method like filtration, if it's a double displacement reaction or something like that. And you end up not being able to get every last bit of that final product. And so when the amount that you recover is different from the amount that you calculated that you should theoretically get, then you have a situation where you've got a less than 100% yield. Now, there's other things that can happen too with your chemical reactions, is that sometimes when you, let's say you have a product and you want to get it dry, so you let it sit and you let the water evaporate. What might happen there is that because you're in an open environment, the product that you try to recover reacts with oxygen in the air, let's say. And so then you get a side reaction taking place that you didn't count on, and now you've got some slightly different product than you initially started with. Now, if that slightly different product adds oxygen to the mix, now you've got possibly a greater than 100% yield. And so there's different scenarios that you can get here, simply because it's almost impossible to get an exactly 100% yield on most chemical reactions. So this is our definition for percent yield, and one of the things that we're going to do is we're going to have to be able to calculate how this works. The equation is actually fairly straightforward. It's simply the percent yield is equal to the actual yield, the stuff that you collect when you carry out the chemical reaction, divided by the theoretical yield, which you calculate using the equations, and you multiply that by 100%. Done. And then, of course, there's this equation which you now need to be able to manipulate. So I should be able to calculate my actual yield using this equation, or I should be able to calculate the percent yield, or even possibly the theoretical yield, and then figure out how much I started with, that sort of thing. So there's different variations that we can use for this. Let's do an example. So suppose we have a ½ gram of potassium carbonate, react that with excess hydrochloric acid, and we get a percent yield of 0.05 grams of water. All right, so there's our chemical reaction equation. Make sure you get those formulas right, guys, because if they're wrong, then everything else, of course, is going to be wrong. All right, so we start with ½ gram potassium carbonate. We're going to have lots of this stuff, so it's not a limiting reagent question. If I gave you an amount here, it would have to be a limiting reagent question, and then you'd follow that scenario. Remember, we get hydrogen carbonate, which breaks up into carbon dioxide and water. Don't forget that guy from our double displacement reactions way back when. And then, of course, our potassium chloride. So what we're looking for is how much of this stuff, the water, is produced. In other words, what's the percent yield of the water? Okay, here we go. So first of all, number of moles of the potassium carbonate. Mass by molar mass, we calculate 0.036 in a bunch of decimal places moles. Theoretically, we should get, using our 1-to-2 ratio, or sorry, 1-to-1 ratio, the same number of moles of water. And so the amount of water in terms of the mass, number of moles times the molar mass, we should get about 0.065 grams of water. So that's our theoretical yield. Now, how do we figure out our percentage yield? Okay, so the question tells us we got an actual yield of 0.05 grams instead of 0.065 grams. Okay, so if that's the case, then we just simply use that as our actual yield. We just calculated our theoretical yield, so that becomes our denominator. 100%, and we get 76.698132%. Rounding, normally I go to 2 decimal places with percentages. Percentages are a little bit different than normal significant digits. Key to this, especially if you're adding up percentages, they have to add up to 100%. Maybe wasn't quite so clear on some of the previous questions on percentages, especially percent composition. But generally 1 or 2 decimal places is fine. Okay. In this particular one, 76.7 would be just fine. Okay. Anyway, so that's it for percent yield. There's the homework questions. Go ahead and try those. That's your work for this week, as well as maintaining, of course, understanding of everything else. Next week we will be having a major project. So there you go.